On the morning of May 5th, 1961, all systems were go for America. On that day, in the early dawn, people throughout the world were watching and hoping. Even after unprecedented engineering and testing programs, not one person could be sure that this man could fly this craft into space and return safely to the Earth. These were tense moments in the early 60s. The risks were great, but they were well taken. The eyes of America and the world watched as Alan Shepard and those thousands who stood beside him made the dream of American manned spaceflight a reality.
Liftoff. Liftoff at 34 minutes after the hour.
After that historic flight, another man of vision and courage, President John Kennedy, set America on a course to the moon.
That we shall send to the moon 240,000 miles away from the control station in Houston, a giant rocket more than 300 feet tall, made of new metal alloys, some of which have not yet been invented, capable of standing heat and stresses several times more than have ever been experienced, fitted together with a precision better than the finest watch, carrying all the equipment needed for propulsion, guidance, control, communications, food, and survival on an untried mission to an unknown celestial body. We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because and measure the best of our energies and skills, because that challenge is one that we're willing to accept. Those who came before us made certain that this country rode the first waves of the Industrial Revolution, the first waves of modern invention, and the first wave of nuclear power. And this generation does not intend to founder in the backwash of the coming age of space. We mean to be a part of it. We mean to lead it. We set sail on this new sea because there is new knowledge to be gained and new rights to be won, and they must be won and used for the progress of all people.
In the brilliance of the lunar success, it is easy to forget those small daily triumphs that were our first steps. On Earth, the first astronauts trained in simulators to master machines more complex than the wildest imaginings of science fiction. As their experience and abilities grew, space became less an unknown void and more a new ocean to be sailed. Worldwide tracking stations had to be established that would circle the globe and make possible communication with spacecraft in orbit. People had to be trained to a high level of competence to operate these widespread links in the thread of communication that stretched far into space. With their cameras, the astronauts became the eyes of all people, looking at their world from a new perspective. Our early views of the Earth from space revealed an unexpected and incomparable beauty. These were days of new hope and confidence. In the final Mercury flight, astronaut Gordon Cooper controlled re-entry by hand and splashed down only 8,700 yards from the prime recovery vessel. America was going to the moon, and every flight brought nearer that ultimate goal. Project Gemini, with spacecraft large enough for 2 astronauts, was America's next step into space. Many questions remained along the pathway to the moon. Could man walk outside his spacecraft and work in space? Gemini flights proved he could. Could 2 spacecraft rendezvous in space? They maneuvered within feet of each other in Project Gemini. In fact, these space travelers lived in space 2 weeks, eating, sleeping, and working without ever leaving their spacecraft. Long-duration flight would be necessary for a mission to the moon. Fuel cells were used on these missions because conventional batteries would not be adequate for the long journey to the moon. Someday, fuel cells may be used on Earth to provide power to our homes and automobiles. Docking one spacecraft with another would be a primary requirement for the lunar journey. In Project Gemini, the spacecraft was docked with the Agena target vehicle. The propulsion system of the Agena was fired to boost the docked spacecraft to a record orbit of 741 nautical miles. And a view of Earth no one had seen before.
The world is real. You got a good view? I mean, it's spectacular.
The base of experience gained in Mercury was refined and extended in Gemini. Everyone in the program knew their job and performed it well. This government and industry team would form the nucleus of expertise required to go to the moon and contribute greatly to new approaches in the management of large projects. Gemini astronauts served science as well as technology. These unique photographs show the ultraviolet airglow phenomenon that is visible from space. Through these pictures, scientists gain new insights into the composition and characteristics of our upper atmosphere. Re-entry flight path control was an important prerequisite for a lunar mission. Returning from the moon at 25,000 miles an hour, spacecraft re-entry must be controlled within 2 degrees. The Gemini spacecraft was designed to be maneuvered to that degree of accuracy, and the Gemini flights proved the success of this technique. The Gemini program built upon the foundation of Mercury, adding new experience to the bank of knowledge and new capabilities to the body of technology that would take America to the moon. At the conclusion of Project Gemini, over 2,400 photographs of the Earth had been taken from orbit. 2,000 of these photographs were used by scientists, geologists, and cartographers throughout the world to vastly increase their understanding of our planet. Fundamental questions about the abilities of man and his spacecraft had been answered, and the 12 flights of Gemini had given us the experience and confidence to take that next step into space. Project Apollo. The immensity of the launch vehicle equaled the enormity of the journey. Every part of this nearly 6 million pound vehicle had been tested and retested, verified and checked. Even before it left the launch pad, this was one of the greatest technological accomplishments in the history of the world. A skilled government industry team had been refined and strengthened throughout early programs to the greatest levels of proficiency in Apollo. Advanced management techniques were developed that have increased cost effectiveness in both government and industry. These same techniques may be used to solve some of our nation's most pressing problems. Hundreds of thousands of highly qualified designers, engineers, scientists, and workmen had aimed for years for this moment, when men from America would land on the moon.
We've been
Tranquility Base here. The Eagle has landed.
The world watched Apollo missions on television as the explorers from Earth searched the surface for geological data that would help in understanding the early history of our planet and solar system. More and more emphasis was placed on scientific activities on the moon. Complex experiments were placed that would continue to send back signals from the moon long after the last Apollo flight had returned home. Today, these signals are expanding the base of lunar science, as well as increasing knowledge of our home planet. Experiments such as these could result in increased accuracy in the prediction of earthquakes and increased understanding of the movement of continents on Earth. Lunar explorers took samples from the moon so that later scientists on Earth could analyze its composition and learn more about our nearest neighbor in space. America's last Apollo astronaut to leave the moon had an appropriate comment.
America's challenge of today has forged man's destiny of tomorrow.
We had already begun our tomorrow. After the long odyssey to the moon, men began to realize that we had seen more than another celestial body. We had seen our own Earth in a way never seen before, as a traveler in space would see it, blue and white and inviting. The worldwide ecology movement dates its beginnings of popular support to pictures like these that show the Earth as a fragile envelope of life in the cold void of space. As we looked closer, we realized there were things to be learned, things to be done nearer to home. Project Skylab, America's first space station, was designed to learn and do those things in near-Earth space that the technology generated by the lunar program had made possible. Large-scale launch vehicles had been proven. Man's viability in space had been established, and previous experience had provided us with the capability to send men to live and work for long periods in space. 147 principal investigators from the world over participated in the scientific accomplishments of Skylab. Skylab was made largely of hardware designed for the Apollo program. The orbital workshop itself was built from an unused third stage of the Saturn V launch vehicle. Returns to science were even greater than had been expected. The giant telescopes aboard Skylab had revealed mysteries of the sun that had been concealed for all recorded history by the dense blanketing atmosphere of the Earth. Pictures like these show faces of the sun never seen before and may contribute to the use of the sun as a limitless source of energy on Earth. Successful experiments were conducted which proved the feasibility of enlarged crystal growth in zero gravity. This could result in greatly improved reliability and miniaturization of sophisticated electronic devices. Pictures of the Earth from Skylab have proven invaluable in locating water and vital mineral resources that would have remained unseen from the surface. For years to come, these orbital photographs may provide solutions to transportation problems by improving shipping routes, solutions to land management problems in the United States and in other countries, and the increased understanding of our oceans and atmosphere. But perhaps the most important contribution of Skylab is the realization that there is no recognizable limit to man's ability to live, to learn, and to produce in space. Man has made this new world his home. Skylab orbits the Earth silently now, its systems powered down. The last astronauts have returned to Earth. But it has shown us that near-Earth space is a resource to be used for the betterment of man. And the international cooperation engendered will hopefully increase and extend to other ventures in space. The final flight for Apollo hardware is the Apollo-Soyuz mission. This mission will link a spacecraft from the USSR with one from the United States. America and the world have come a long way since those early days in space. The spirit of this project lends hope that space can be used for the benefit of all people as an example of peaceful cooperation. With the final flight of an Apollo spacecraft, an era is formally brought to a close. But a new age is already born, an age of international cooperation and the use of our most abundant natural resource, space. On this new ocean, America will use a versatile and economical spacefaring vehicle, the Space Shuttle. Its large payload bay will accommodate everything from many small satellites to full-size manned laboratories that may operate for weeks in Earth orbit. The Space Shuttle has evolved from the foundations of earlier programs and utilizes the advanced technology and management techniques developed in Mercury, Gemini, Apollo, and Skylab. Launch costs for the Space Shuttle will be reduced to a fraction of those of expendable vehicles because the shuttle will be reusable. The fields of science, earth resources, medicine, and the manufacture of new alloys and materials will be greatly advanced by the capability of the Space Shuttle to carry a variety of payloads. For example, the Space Lab, which is being developed by 10 European nations at their own expense, will provide a shirt-sleeves environment for scientists and engineers to conduct valuable experiments in orbit and then return to Earth with their results. This capability to routinely work in the weightlessness of space will provide opportunities such as the production of new alloys for manufacturing and the development of new medical techniques and vaccines. Tomorrow, all nations may work together in space for the benefit of mankind. In the words of John Kennedy, there is still new knowledge to be gained and new rights to be won for the progress of all people. Those first steps, Mercury, Gemini, Apollo, and Skylab, opened the door to space. Today, we stand on the threshold of opportunity.